Welcome to this GCSE chemistry presentation on quantitative chemistry. In this video, we'll explore the key concepts and calculations that underpin chemical quantities and reactions. Scope and importance of quantitative chemistry are relative atomic mass, R, and isotopes, and relative formula mass, Mr, calculations. Quantitative chemistry is a core area of chemistry specification because it provides the mathematical tools needed to measure, predict, and analyze chemical reactions accurately. Relative atomic mass, known as R, is a fundamental concept in quantitative chemistry and is defined as the weighted mean mass of an atom of an element compared with 1/12 of the mass of a carbon-12 atom. In the AQA GCSE course, students are expected to use values provided in the periodic table to carry out further calculations involving moles and masses. Relative formula mass, or Mr, is the total of the relative atomic masses of all the atoms present in a chemical formula. Mr calculations are used extensively as a bridge between the mass of a substance and the amount of substance measured in moles. First, let's talk about the conservation of mass. In a chemical reaction, atoms are neither created nor destroyed. This means the mass of the products equals the mass of the reactants. To reflect this, chemical equations must always be balanced. At its heart, quantitative chemistry links the microscopic world of atoms and molecules to the macroscopic measurements made in the laboratory, such as mass, volume, and concentration. Students are expected to understand not only how to carry out calculations, but also why those calculations are meaningful in real chemical contexts. The mole concept and Avogadro constant, calculating moles from mass, calculating mass from moles. The mole is a central concept in quantitative chemistry and provides a way to count particles such as atoms, molecules, and ions. 1 mole is defined as the amount of substance that contains 6.02 times 10 squared cubed particles, a number known as the Avogadro constant. One of the most common calculations in quantitative chemistry is finding the number of moles of a substance given its mass. The key formula used is moles equals mass divided by Mr. This simple relationship allows chemists to convert a measured mass into an amount of substance, which can then be used in further calculations involving chemical equations. Calculating the mass of a substance from a known number of moles is the reverse of calculating moles from mass and uses the formula mass equals moles times Mr. This calculation often appears in questions involving chemical reactions and yields. To carry out this calculation, students must again start by identifying the correct Mr. of the substance. The relative formula mass, or Mr, is the sum of the atomic masses of all atoms in a compound. For example, water, HO, has a relative formula mass of 18. A mole represents a fixed number of particles, 6.022 times 10 to the 23. It allows chemists to count atoms and molecules in bulk. This type of calculation is commonly used after determining mole ratios from a balanced equation. For instance, students might first calculate the number of moles of a reactant and then use the equation to find the number of moles of product formed. In a chemical reaction, the limiting reactant is the one that's used up first. It limits the amount of product that can be formed. Practicing these calculations helps reinforce the relationship between mass, moles, and Mr, which is central to all quantitative chemistry. Accurate and precise measurements are essential in chemistry. Always use suitable units and consider significant figures to ensure reliability in calculations. Percentage yield compares the actual amount of product obtained with the theoretical maximum. It's a measure of how efficient the reaction was. Atom economy evaluates how many of the reactant atoms end up in useful products. A higher atom economy means less waste and a more sustainable process. Accuracy and unit awareness are crucial. Students should always include units in their answers and ensure that masses are given in grams, as expected by the specification in the topic. Balanced equations and mole ratios, limiting reactants. Balanced chemical equations are essential tools in quantitative chemistry because they show the ratio in which substances react and are formed. Students must be able to use these ratios to carry out calculations involving reacting masses and amounts of substance. Each coefficient in a balanced equation represents a mole ratio, not a mass ratio. Limiting reactants are an important concept in quantitative chemistry. The limiting reactant is the substance that is completely used up first in a chemical reaction, thereby limiting the amount of product that can be formed. Any other reactant is described as being in excess. Calculating concentration of solutions, gas volume calculations at RTP, percentage yield, and atom economy. When a gas is a reactant or product, it can affect mass measurements. For example, When magnesium reacts with oxygen from the air, the product seems heavier because oxygen from the air is added. Concentration calculations describe how much solute is dissolved in a given volume of solution. Concentration can be expressed in grams per cubic decimeter, g/dm cubed, or moles per cubic decimeter, mol/dm cubed. At room temperature and pressure, 1 mole of any gas occupies 24 cubic decimeters. You can use this to calculate gas volumes in reactions. Gas volume calculations are based on the idea that at room temperature and pressure, RTP, 1 mole of any gas occupies 24 dm cubed. Percentage yield and atom economy are calculations that link quantitative chemistry to industrial processes and sustainability. Percentage yield compares the actual amount of product obtained from a reaction to the theoretical maximum predicted by calculations. Concentration tells us how much solute is in a solution. It's calculated by dividing moles of solute by volume in cubic decimeters. You can use the formula triangle to calculate concentration, moles, or volume. Always convert cubic centimeter to dm cubed by dividing by 1000. The amount of a substance is measured in moles. To calculate it, divide the volume by the volume at RTP, molar volume. Balanced chemical equations show the ratio of moles of reactants and products. These ratios help calculate reacting volumes. Titrations and volumetric analysis, exam technique, units, and summary. Titrations are a practical application of quantitative chemistry and are assessed as both calculations and required practical knowledge. A titration is used to find the concentration of an unknown solution by reacting it with a solution of known concentration, usually involving an acid-base neutralization. In a typical titration, a known volume of alkali is placed in a conical flask, and acid is added from a burette until an indicator shows that neutralization has occurred. Students must understand the apparatus, the role of indicators, and how to record accurate results. Titration calculations involve several steps: converting volumes from cubic centimeter to dm cubed, calculating moles using concentration, applying mole ratios from the balanced equation, and finally calculating the unknown concentration. For example, if 25.0 cubic centimeters of sodium hydroxide is neutralized by 20.0 cubic centimeters of 0.100 mol dm cubed hydrochloric acid, students can calculate the concentration of the sodium hydroxide as 0.080 mol dm cubed. Careful unit conversion is one of the most common challenges. Volumes must often be converted from cubic centimeter to dm cubed, and students should check whether answers are required in grams, moles, or mol dm cubed. Rounding should be done appropriately, usually to the number of significant figures given in the question. This topic brings together many interconnected ideas, from atomic masses and moles to concentrations and titrations. Revising quantitative chemistry effectively involves practicing a wide range of questions and understanding how different calculations link together. Drawing flow diagrams or step-by-step methods can help structure problem solving. To summarize, we've explored the fundamental concepts in quantitative chemistry, from conservation of mass to concentration and atom economy. To master these, be sure to practice with calculation problems. Thank you for watching.